guys want to add? Jacob?
Can I turn my name on?
Yep. Anybody have any questions for him, or we get it?
No. Oh, 26 through 28.
Oh, 25 and what?
Yeah, so it's like 28. 26 and 27. Can we do 28?
Uh-huh. Oh, just a review one? Okay.
Yeah.
28.
All right. So 25, you're given two different options for pizza. You can get a pizza that is 16 inches in diameter for $12.50, or 20 inches in diameter for $20. And you got to figure out which is better by. What do we need to figure out about the pizzas in order to answer this problem? What? Okay.
How much?
Yeah, got to figure out the area of the pizza, because when you're buying pizza, that's essentially, assuming all the ingredients and the sauce and all that is the same, when you're buying pizza, you're paying for the area that you're getting. So what is the formula for the area of a pizza? IR squared. So if my diameter is 16 inches, then that means the radius must be 8. And so what would the area of this pizza be? 64 pi. And if this one has a 20-inch diameter, then that means the radius is 10. And so that means that the area must be 100 pi. Okay? All right, so we got the area of the pizzas figured out. How does that help us? By the price? Okay? So if I take the area of this one, 64 pi divided by 1250, what do you get? Okay, let's do it just for funnies up here. 64. Probably those. There. 64 pi divided by, how much is that pizza? 1250. Okay, that gives me 16.08. And the other one was 100 pi divided by, how much did that one cost? 20? Okay, so that gives me 15.7. So the question is, in this case, do we want the bigger number or the smaller number? Why?
Oh, wait, no.
Why? In what situation would we want the smaller number? If it's the cost, right? But what the way Alyssa told me to do it was divide the area by the cost. So this is the amount of pizza per dollar, and this is the amount of pizza per dollar. So in this case, do we want the bigger one or the smaller one? We want the bigger one. So we want the bigger answer. So that corresponds to the first one, which was 16-inch diameter. You could also have answered this problem correctly if you had done it the other way around. If you had taken the price of the pizza divided by the area, and then if you took the price of the other pizza divided by its area, then you would end up reaching the same conclusion in a different way. And I clearly did something wrong there. Thank you. Oh, it wasn't 16 pi, was it? It was 64 pi. This time, if you do the price divided by the area, which one do you want, the bigger or the smaller? This time you would want the smaller, because this time you would be looking for paying the fewest amount of money per square inch or something like that. So no matter which way you do it, you come up with the 16-inch pizza being a better deal, okay? All right, same idea for number 26, but now we're talking about ice cream. Ice cream comes in two different kinds of containers. Cylindrical containers and boxes. And I learned early on in my marriage that if my wife asked me to get ice cream for any reason whatsoever, and I bring her home ice cream in a rectangular box, she might divorce me. Okay? Because in her mind, the ice cream that comes in the cylinder containers is always better than this one. Like, these are the cheap brands. And these are the, this is the Ben & Jerry's and the Breyers and the, and this is like the Western Family, and isn't there a bunny one, a blue bunny or something like that? Yeah, I don't know. I don't care. I just want to eat a lot of ice cream.
I know, I just
But,
took off the plate.
Anyway, so it says, this has a diameter of 6 inches and a height of 8 inches, and it costs $3.98. This has a square base, I didn't draw that very well, with 6 inches on each side, 8 inches tall, and it costs $4.98. So this time, unlike with the pizza situation, instead of trying to find the area, what should I be finding? The volume, because ice cream comes in volume. So what's the formula for the volume of this cylinder? The area of the base times the height is correct, yeah. So what would the area of this base be? 9 pi, because the radius is 3, and 3 squared is 9. So I'm going to go 9 pi times the height of 8. So that comes out to have a volume of 72 pi. What's the volume of this guy? How do I find that? Same thing, right? Area of the base times the height. Well, what's the area of this base if it's a square 6 inches on either side? 36, and then 36 times 8 is 240 plus 40 is 308. Looking at something with the calculator? 288? Oh, yeah. 288. Okay, so now, hey, shh. They're just sitting right by the microphone. Which one do you want to do? Do you want to divide the volume by the price and look for the bigger number, or do you want to divide the price by the volume and look for the smaller number? Okay, you want to look for the bigger number. So I'm going to go 72 pi divided by, what was the cost of that? $3.98. Okay, and then the other one had a volume of 288. And how much did it cost? $4.98. Okay, so survey says the ice cream in the box was a better deal. Just barely. Not by much. All right, and then did you say number 27? Didn't we work through 27 in class? Yeah. Okay, so we don't need that one? All right, 28. 28 is a pretty straightforward review. We have a sphere and we need to find its volume and its surface area, and we know that the radius is 6 feet. Okay? So, what's the formula for the volume of a sphere? Do you recall? Something with a pi, yes. What? 4/3 pi r cubed. Okay? What's the formula for the surface area of a sphere? 4 pi r squared. Okay, and so to figure that out, I'm not going to work this out for you. All you need to do is, if you look at the picture, the radius of the sphere is, 6 inches, I think, not 6 feet. Oh, no, it is 6 feet. You just need to plug in 6 for the radius into those things and come up with your answer from that. All right? Okay, will you pass those forward, please?